Hi everyone, my name is Tasheia Floyd, and my Algodoo project will focus on the conservation of energy, specifically gravitational potential energy, translational kinetic energy, and potential energy of a spring. So, here I have a very simple setup that I know will illustrate the real time transformation of energy of a system. Here's a ramp that I'll say is 18 meters in height. Unfortunately, Algodoo doesn't provide that measurement. I created this ramp using the combine shapes and cut option, making a big rectangle, placing a large circle on top of it, then cutting it to create a curve that ends straight. And in order to just focus on the three types of energy mentioned above, I've made the material of the ramp wood and frictionless, as you can see here. So there's no friction and it's wood. So friction will not have to be considered in the transformation of energy of this system. Next, I have a 1,000 kilogram car that I made using the brush tool. The car has two identical wheels that both contain an axle with the front motor set at 45 RPM. So here's the motor, 45 RPM for both the front and rear axles. I've also displayed the energy and velocity vectors of the car. At the end of the, we'll say, 11-meter long ramp is a 400 kilogram box attached to a 45-meter long spring at rest, meaning it's unstretched or uncompressed. And the spring has a spring constant of 8,000 newtons per meter, and it is attached to a fixated post. So before I hit play, we see that the car is at rest. All of the energy in the car at rest is gravitational potential energy. Now I'll hit play, and as the car travels down the ramp, it loses gravitational potential energy to translational kinetic energy of the car since it's now in motion. At the bottom of the ramp, the total energy of the system is completely translational kinetic energy. So once the car hits the box, that translational kinetic energy is completely translated to potential energy of the spring. And since the spring oscillates back and forth colliding with the car, the total energy of the system, which is decreasing over time, is transformed from spring potential energy to translational kinetic energy, back and forth, until there is no more energy in the system and both objects are completely at rest. Now, it's cool to see how energy can be transformed in the real world. But what's great about Algodoo is that we can also visualize the energy in this system using plots. So if I go to the car and click on Show Plots, I can zoom in just so we know that we're focused on the car. And instead of speed being in the y-axis, I can look at the total kinetic energy, gravitational potential energy, and then just the total energy of the system in the car, or just the total energy of the car. We also want to know what the spring energy is looking like, or the show plots. We want to know what the potential spring energy, as well as just the total energy in the system of the spring, is looking like. So I'm going to press play and pause just so we see what the initial energies are. So the total initial energy of the car is 7,000 joules, and all of that energy is gravitational potential energy, as would be expected. The car is 18 meters above the ground and at rest, so we wouldn't expect any translational kinetic energy at this time. Also, since the spring is not moving, there is no spring potential energy. The initial 200 joules that was in the spring is due to oscillation that happens just upon pressing play. So once I press play again, we see that the car travels down the ramp and that the gravitational potential energy is decreasing as the translational kinetic energy is increasing. So at the very bottom of the ramp, we see that the gravitational potential energy reached zero. And then once the car collided with the box, there was almost a plateau. And at this point, all of the energy was transferred from translational kinetic energy into potential energy of the spring. And then we just see a back and forth oscillation of the spring, which translates to back and forth transformation of energy from translational kinetic energy to potential energy of the spring. And this back and forth transformation will continue until all of the energy in the system is zero and both objects are at rest. What's great about Algodoo is that it demonstrates how in the real world, objects don't always collide once. Depending on the materials of the objects, mass of the objects, and other factors, objects can continue to collide until no more energy is able to be transferred, which is what my Algodoo simulation showed here. One limitation of Algodoo was that there was no way of obtaining height of the ramp I created, which is useful in calculating gravitational potential energy of the car. Finally, there was no option to plot rotational kinetic energy of the wheels, which would also be an energy in this system worth exploring. I hope you enjoyed my project. Thank you.